So take this question. This is very, very important LAQ from sphere chapter. So find the equation of the sphere that passes through 2 points and cuts orthogonally the two spheres. So 2 points are given and two sphere equations are given. So first let us write down equation of the sphere. Let the equation of sphere be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Let's take this as equation number 1. Now since equation number 1 passes through first point, so whenever points are given, we need to pass them through the first equation. So passing through the first equation 0, comma 3, comma 0, which means we need to substitute this point in the first equation in the place of x, y and z. So 0 square plus 3 square plus 0 square plus 2u into 0 plus 2v into 3 plus 2w into 0 plus d is equal to 0. So zeros we can simply remove because anything into 0 becomes 0. So we write 9 plus 6v plus d is equal to 0. So you get d is equal to minus 9 minus 6v. So after finding d value, we need to substitute, we need to pass this first equation through the second point. So since equation number 1 passes through minus 2 comma minus 1 comma minus 4, so we are substituting in equation number 1. So we get minus 2 whole square plus minus 1 whole square plus minus 4 whole square plus 2 into minus 2 into u plus 2 into minus 1 into v plus 2 into minus 4 into w plus d is equal to 0. So we get 4 plus 1 plus 16 minus 4u minus 2v minus 8w plus d is equal to 0. So minus 4u minus 2v minus 8w plus d is equal to minus 21. Okay, so this is equation number 3. The last we got in the here over here we got d value, right? Take this as equation number 2 and this is equation number 3. Now also equation number 1 cuts the sphere. The sphere equation I write it down y square x square plus y square plus z square plus x minus 3z minus 2 is equal to 0 orthogonally. So I have already given you orthogonal condition. So from this sphere equation we find u, v, w and d values. So u is half of coefficient of x and v is half of coefficient of y. But there is no y term here. So v becomes 0. W is minus 3 by 2 and d is minus 2. Now from the condition of orthogonality, what do you get? From the condition of orthogonality, I already told you orthogonal condition is 2u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus d2. So 2u into 1 by 2 plus 2v into 0 plus 2w into minus 3 by 2 equals to d minus 2. So we get over here 2 to cancel. We get u minus 3w equals d minus 2. So u minus 3w, we bring both terms to the left hand side. So we get minus d plus 2 equals to 0. So u minus 3w minus. Now from equation number 2, I am substituting d value. We got d as minus 9 minus 6v plus 2 is equal to 0. So u minus 3w plus 9 plus 6v plus 2 is equal to 0. So u plus 6v is equal to uh, plus 11 is equal to 3w. So if you find out w value, you get w equals to 1 by 3 into u plus 6v plus 11. Let's say this is equation number 5 and we will take this as equation number 4. So equation number 1 cuts the sphere. Which sphere? 2 into x square plus y square plus z square plus x plus 3y plus 4 is equal to 0. So if I take 2 common, we get x square plus y square plus z square plus x by 2 plus 3 by 2 y plus 2 is equal to 0. So you get u is equal to 1 by 4, v is equal to 3 by 4, d is equal to 2. Now from condition of orthogonality, 2u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus d2. So 2u into 1 by 4 plus 2v into 3 by 4 plus 2w into 0 is equal to d plus 2. So 2 ones are 2 twos are 2 ones are 2 twos are. So we get u by 2 plus 3v by 2 minus d minus 2 is equal to 0. So we take the LCM to u plus 3v minus 2d minus 4 is equal to 0. So u plus 3v minus 2 into, in the place of d we substitute d value from equation number 2. So that is minus 9 minus 6v minus 4 is equal to 0. So u plus 3v plus 18 plus 12v minus 4 is equal to 0. So u plus 15v plus 14 is equal to 0. This is equation number 6. Now substituting equations 2 and 5 in equation number 3. So we get minus 4u minus 2v minus 8 into 1 by 3 into u plus 6v plus 11 plus d is minus 9 minus 6v plus 21 is equal to 0. So if we further simplify, we get minus 4u minus 2v minus 8 by 3 into u plus 6v plus 11 minus 9 minus 6v plus 21 is equal to 0. So now we take the LCM. So we get minus 12u minus 24v minus 8u minus 48v minus 88 plus 36 is equal to 0. So we get minus 20u. See, minus 12u minus 8u is minus 20u. Minus 24v minus 48v is minus 72v. Minus 88 plus 36 is minus 52 is equal to 0. If I take minus 4 common, we get 5u plus 18v plus 13 is equal to 0. Let's say this is equation number 7. Now solving equation 6 and 7. So you get from sixth equation I am taking 15, 1, 14, 15. Then over here we have to take v coefficient first, then constant, then u coefficient and then again v coefficient. And over here we write u, v and 1. Now you cross multiply. So you will get u by 1 minute. I'm mistaken here. There is a w term missing in seventh equation. So we write first 18 and then 5, 13 and 18. Okay, so now if you cross multiply, you will get u by 57 is equal to v by minus 57 is equal to 1 by 57. So you get u is equal to 1, v is equal to minus 1. Now from equation number 2, d is equal to minus 9 minus 6 into minus 1. That is d is equal to minus 3. Now from equation number 5, we get W. W is 1 by 3 into 1 plus 6 into minus 1 plus 11. That is equal to 2. So we got U as 1, V as minus 1, W as 2 and D as minus 3. Now substituting corresponding values in equation number 1. So we get x square plus y square plus z square plus 2x minus 2y plus 4z minus 3 is equal to 0. This is the required equation of the sphere. Now take the next question. This model is also very, very important. Find the limiting points of the coaxial system defined by spheres x square plus y square plus z square plus 4x minus 2y plus 2z plus 6 is equal to 0. And x square plus y square plus z square plus 2x minus 4y minus 2z plus 6 is equal to 0. We need to find the limiting points of the coaxial system and two sphere equations are given to us. So we will write given sphere equations as be denoted by S1 and S2. So S1 is x square plus y square plus z square plus 4x minus 2y plus 2z plus 6 is equal to 0. And the second sphere equation as S2 x square plus y square plus z square plus 2x minus 4y minus 2z plus 6 is equal to 0. Now let us write down what is equation of plane of circle through two spheres. Through two spheres is S1 minus S2 equals to 0. So just you need to subtract these two sphere equations. So we write one below the other first. X square plus y square plus z square plus 4x minus 2y plus 2z plus 6 is equal to 0. And x square plus y square plus z square plus 2x minus 4y minus 2z plus 6 is equal to 0. If we subtract them, we change the signs minus, 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 plus, plus, minus. So x square, y square, z square cancel, 6 also cancel. 4x minus 2x is 2x plus 2y plus 4z is equal to 0. So if I take 2 common, we get x plus y plus 2z is equal to 0. Now we need to find out equation of coaxial system of spheres. Formula is S1 plus lambda into S1 minus S2 is equal to 0. Now we substitute S1 and S2 over here. So what is S1? X square plus y square plus z square plus 4x minus 2y plus 2z plus 6. And what is S1 minus S2? Plus lambda into x plus y plus 2z is equal to 0. So x square plus y square plus z square plus 4x minus 2y plus 2z plus 6 plus lambda x plus lambda y plus 2 lambda z is equal to 0. So now we take x, y, z common. So x square plus y square plus z square we write as it is. From these two terms we take x common. So we got 4 plus lambda into x. From these two terms we take y common. So we get minus 2 plus lambda into y. And from these two terms we take z common. So 2 plus 2 lambda into z plus 6 is equal to 0. Now we are comparing above equation with standard equation. With standard equation of sphere. What is the standard equation of sphere? X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. So you get u is equal to 4 plus lambda by 2, v is equal to minus 2 plus lambda by 2, w is equal to 1 plus lambda, and d is equal to 6. So we know that center is equal to minus u comma minus v comma minus w, that is minus of 4 plus lambda by 2 comma minus of minus 2 plus lambda by 2 comma minus of 1 plus lambda. Now we need to find out radius. So radius r is equal to root over minus of 4 plus lambda by 2 whole square plus minus of 2 plus minus 2 plus lambda by 2 whole square plus minus of 1 plus lambda whole square minus 6. So that is equal to root over minus square will become plus. Now we are expanding a plus b whole square. 16 plus lambda square plus 8 lambda by 4 plus 4 plus lambda square minus 4 lambda by 4 plus 1 plus lambda square plus 2 lambda minus 6. So that is equal to square root of, if I take LCM, we get 16 plus lambda square plus 8 lambda plus 4 plus lambda square minus 4 lambda plus 4 plus 4 lambda square plus 8 lambda minus 24 whole divided by 4. So that is root over. Now lambda square plus lambda square is 2 lambda square. 2 lambda square plus 4 lambda square is 6 lambda square. Now 8 lambda plus 8 lambda is 16 lambda. 16 lambda minus 4 lambda is 12 lambda. Now 16 plus 4 is 20. 20 plus 4 is 24. 24 minus 24 becomes 0. So simply I can write by 4. Now after finding radius, we need to check the limiting points condition. So for limiting points of coaxial system, radius is equal to 0. So the radius which we got, root over 6 lambda square plus 12 lambda by 4 is equal to 0. So if I square on both sides, we get 6 lambda square plus 12 lambda by 4 is equal to 0. If I cross multiply, you get 6 lambda square plus 12 lambda is equal to 0. If I take 6 lambda common, we get lambda plus 2 is equal to 0. So if I take 6 that side, it becomes lambda into lambda plus 2 is equal to 0. So we get lambda value as 0 and minus 2. Now we need to substitute these lambda values in center and radius. So first let us take for lambda is equal to 1. Sorry, for lambda is equal to 0. Center is minus of 4 plus 0 by 2, comma minus of minus 2 plus 0 by 2, comma minus of 1 plus 0. That is minus 2 comma 1 comma minus 1. And for lambda is equal to minus 2, we need to find center again. We need to substitute lambda is equal to minus 2 here. So you get minus of 4 minus 2 by 2, comma minus minus 2 by 2, comma minus of 1 minus 2. So that is minus 1, 2 and 1. So these are the limiting points. So limiting points are minus 2 comma 1 comma minus 1, and minus 1 comma 2 comma 1.